Hello everyone, you are welcome to today's episode in this channel, African Science and Humanities Review. Today we want to consider some fundamental laws in thermodynamics. What do we mean by thermodynamics? In a layman's sense, thermodynamics can be described as the dynamics of thermal processes, of thermal phenomena. When we talk about thermodynamics, it's a combination of two words, thermo and dynamics. Dynamics talks about the mechanics aspect, which is motion, and thermo talks about the heat. So we have some fundamental laws of thermodynamics, and they are called the laws of thermodynamics, the Zeroth law of thermodynamics, the first law of thermodynamics, the second law of thermodynamics, and the third law of thermodynamics. These laws govern thermodynamical processes. And today we are going to start by examining the Zeroth law of thermodynamics. Please stay tuned and enjoy the episode. Thank you very much. Thermodynamics. So we can see that this word, thermodynamics, is a combination of two distinct words. Thermo and dynamics. As we can see in this simple sketch, thermodynamics, thermo, which can simply be explained, defined as heat, anything relating to heat. Remember thermometer, the instrument that is used to measure the temperature. So anything thermal, you are referring to heat. And then the dynamics, which describes the aspect of the phenomena relating to motion. As we know, based on our previous episode, dynamics is one of the two distinct areas of mechanics. When you talk about mechanics, you can talk about statics, and you can talk about dynamics. And as we explained in an earlier episode, dynamics deals with the issue when the body, the object you are considering, is in motion, or things relating to the object, the system, being in physical motion. And the statics refers to the phenomena in which the object or the system is at rest. What are the forces that apply to the object, and so on and so forth. So, here we are talking about the motion of heat processes. You know, when you heat a substance, an object, there is a certain kind of motion, and that motion can be described using thermodynamics. Another area, another field, so to say, of physical science in which thermodynamics is studied, or another word for the field of study that deals with thermodynamics, is statistical physics. As the name implies, there is a lot of statistical principles, probability measures that are involved in studying motion of this type. So thermodynamics, dynamics of thermal systems. So we want to look at a simple illustration of the behavior of a thermodynamical system, of a system which behaves, which is subject to heat and makes some behavior relating to dynamics, motion. So water, fluid being boiled. Of course, we know that water is a fluid. What is a fluid? about fluid. You can talk about water, liquid, and you can also talk about gas. As we mentioned in an earlier episode, even the whole concept of fluid is also another area that is called fluid mechanics. And even within the fluid mechanics, you can talk about the fluid dynamics and the fluid statics, and the dynamics or the mechanics that deals with water itself is called hydromechanics or hydrodynamics. Wherever when you are talking about the motion of the object. So here we just simply want to use a fluid, which is water. As we said, water, liquid can be a fluid, gas can be a fluid, and water is an example of fluid. So we can see we are using this to represent a kettle, and we have the water inside the kettle, and we are applying heat to it. Of course, there are various ways in which heat can be applied. Your simple stove, pressure cooker, and so on and so forth. So when you apply the heat, the particles, the water, you can see this is the water, but it will be in motion. The heat will change the state of the particles of the water, and they keep on moving. And at a stage, it becomes hot, because the whole idea is to bring about heat energy. The energy relating to that will generate via heat. And we have explained what energy is with respect to the law of conservation of energy. So we can see the water here, and of course we know that in a large scale procedure involving heating of water like this, when you have the steam can also be used to generate light energy. It can have kinetic energy and so on and so forth. So, but this is a simple illustration. You apply the heat to the water, then the water becomes hot, and there's heat energy, and that heat energy can also be used, in other forms of area. You can use it to generate other forms of energy, and we know the law of conservation of energy also covers this. Then we can now look at the basic behavior of matter under applied heat. Of course, we know matter, anything that has, weight, and just any substance, so to say, is matter. But you can consider matter basically to exist as either solid or liquid or gas. And of course, if it exists as liquid or gas, then it's a fluid. Of course, there is mechanics for solids also. We have the solid state mechanics. So as we have specific mechanics that deals with solid objects, we have specific mechanics that deals with liquid, water, hydrodynamics, and we also have specific area that deals with fluid mechanics, in which you only talk about the liquid and the gas. So we have a typical solid. It could be like your cube of sugar, for instance. When you apply heat to it, it turns to liquid, it melts, becomes liquid, and you keep on applying, then it turns to the gas. It turns to its gaseous state. And that's when you start seeing the vapor coming out. So it's a simple illustration of the transition from the solid state to the liquid state to the gaseous state. And of course, whatsoever energy you generate in line with the law of conservation of energy can be converted from one form to the other. But the total amount of energy remains the same. So we now want to look at the laws of thermodynamics. Having explained that thermodynamics deals with the dynamics of heat processes, heat phenomena, what are the laws that govern thermodynamics? Because we know that thermodynamics is also within mechanics, but it's a specialized area, it's a peculiar area of mechanics. So apart from the general principles of mechanics that apply to all objects, there are specific laws that apply to thermodynamical systems. And one of the famous laws, a foundation law, foundation group of laws which cover thermodynamics, that's called the laws of thermodynamics. They are called laws because they are not just one or two. So you can have the Zeroth law of thermodynamics, the first law of thermodynamics, the second law of thermodynamics, and the third law of thermodynamics. So let's see how each of these laws operate. Zeroth law. This law of thermodynamics is a law of transitivity. It's a transitive law in the sense that when you talk about a law that is transitive, you are referring to systems in which the first system is in a relation with a second system, and the second system is in relation to a third system, which makes us to imply that the first system is in relation to the third system. That is simply what transitivity means with respect to physical science. Of course, you also have reflexive law, you have symmetric law, you have anti-symmetric law. But with respect to Zeroth law, it's the transitive law that is obeyed. So what Zeroth law essentially says is this. We have two conditions. We have initial condition 1, and then you have initial condition 2. Those are the premises upon which the Zeroth law is based. So you have a system A, which is in thermal equilibrium with another system C. So we are using this to show equilibrium. You know, when you talk about equilibrium generally, you are talking of a system or systems that are at rest, so to say. So Zeroth law indirectly deals with systems that you can refer to as being at rest in their zeroth state, so to say. So you have system A that is in thermal equilibrium with system C. Then you also have system B is in thermal equilibrium with system C. Of course, we could have said also if system B is in thermal equilibrium with system C, it implies that system C is in thermal equilibrium with system B. That is actually the reflexive principle. So that's why we could have said, we could have put C here and put B here. It doesn't matter. If a system is equivalent to another, is in thermal equilibrium with another system, the second system is also in thermal equilibrium with the first system. So that is the relation. That is the concept of reflexivity, reflexive law. But actually, it's the transitive law that we want to explain that the result of the Zeroth law gives transitive relation. So system A is in thermal equilibrium with system C, and system C is in thermal equilibrium with system B. Then what Zeroth law essentially says is that your system A must necessarily be in thermal equilibrium with system B. Okay? We have A and B, they are in thermal equilibrium with themselves. A and C, they are in thermal equilibrium with themselves. B and C are in thermal equilibrium with themselves. So you can extend and say that with respect to thermal equilibrium, that system A is actually must be in thermal equilibrium with system B. That is essentially what Zeroth law says. We believe the shall enjoy today's episode, where we consider the Zeroth law of thermodynamics. In the subsequent episode, the next episode, we are going to look at the other laws of thermodynamics. That is to say, the first law of thermodynamics, the second law of thermodynamics, and the third law of thermodynamics. We shouldn't forget that we are considering these laws as part of the laws of nature. And as we explained in earlier episodes, when you talk about the laws of nature, with respect to this channel, you can talk about the laws of science, the laws of theology, and the laws of philosophy. So we are still considering the laws of science and mechanics, which is the branch of science that deals with motion, is really very, very vital in this channel. And when you talk about this channel, we are talking about the synergy, the interrelationship among science, theology, and philosophy. Indirectly, the physical, spiritual synthesis, the connection between the physical and the spiritual. Because we believe in this channel that both are related. It's more or less talking about the cause and effect. So if you want to have deep understanding of the spiritual, so to say, you have to have an understanding of the physical. Because in many cases, what happens in the physical replicates in the spiritual. And it's also believed that before something happens in the physical, that a related phenomenon must have happened in the spiritual sphere. That's why the two happen. So it's very important for us to understand not just the laws, the spiritual laws, but also the physical laws. And by understanding these physical laws, they really help us to have a balanced understanding of the workings of nature. Thank you very much.